All right, real quick, we're going to talk about literal equations. A literal equation is an equation that consists primarily of letters, formulas, for example. So it has more than one variable, all right, in it to be a literal equation. Doesn't mean there aren't any numbers. It just means that there's more than one variable. All right, and steps that we're going to take in order to solve a literal equation for a specific variable is that we're going to circle the variable that we're looking for. All right, then we're going to draw the line down the equal sign, right, to make sure that we recognize that there is an equal sign there. All right, and then we're going to distribute if possible. We're going to combine like terms, right? We're going through the steps, and then we're going to move the variable that you're solving for. Make sure it's on the left side. And finally, we're going to move everything else to the other side. All right, so let's get into an example. All right, we have, this says solve m plus a equals p for m. All right, so we're going to get in here. All right, this m plus a equals p. And we're going to go ahead and circle the variable that we're looking for. It's m. All right, it's m. So let's go ahead and draw our line, right, to represent equality. And if we look over here, notice that the m is by itself, but not completely on the left side. It has a plus a. And in order to solve for m, we have to get rid of the plus a, so we need to do our inverse operations, right? There are no terms to combine, right? No distributive property. But we can make sure that this m is left to the left side on its own. So let's do that. Our inverse operation of addition is subtraction. So we subtract a from each side. All right, recognize that p and a are not like terms, so we don't need to start trying to combine them. A minus a, that crosses out, bring down our m. So we have m equals p minus a. There we are. All right, and that's really it. We've solved for m. All right, now let's get to this next problem. It says solve v equals LWH for w. All right, don't forget that when we see letters grouped together like this, LWH, that just means, right, L times W times H. Okay, and what we're going to do is go ahead and circle that we're looking for our W, right? And so let's do that. Since we're dealing with multiplication, we need to do the inverse of it, which is division, right? Let's draw our line here. And we're going to divide each side by what's attached to our W, right? Since both of these are multiplication, we can only do this because both of them are multiplication. We can go ahead and divide by both L and H on each side. When we do that, the L's cancel, and so does the H. Again, we can only do this because it's all multiplication here on the right side. Once we do that, we're going to bring down the W that remains, put our equal sign, and we have V over L H. All right. So we didn't move our variable to the left side, but we can do it now. Remember, a property of equality says if A equals C, then C equals A, right? So since that's true, instead of saying V over LH equals W, we can go ahead and just say W equals V divided by LH. All right, and that's our answer. This next problem says solve for x plus 2y equals 12 for y. All right. So let's go ahead and circle what we're looking for. We're looking for y. All right. Let's go ahead and draw our line down the equal sign. And from here, what we need to recognize is that on this left side, the y is attached to the 2y, right? So we're going to deal with this term, this last. Let's go ahead and take care of the 4y, right? Since it's being added to 4x. Since it's being added to the 2y, let's go ahead and subtract. By subtracting, we're left with 2y is equal to, now 12 and negative 4x are not like terms, so we don't need to try to combine them in any sort of way. So we just write negative 4x plus 12. Notice that what we're solving for, y, is already on the left side, so we don't need to move that at all. There's no distributive property or combining like terms. 9 times out of 10, there won't be any of that in a literal equation. So, like I said, it may apply every now and then, but I don't think we'll see it. All right, so now what we're going to do is take it a step further and solve for y. And we're going to do this by dividing by 2. So finally, we can write that y is equal to, well, it looks like we have a negative 4x plus 12. So how we can look at this is negative 4x divided by 2 plus 12 divided by 2. We can separate in that way. Negative 4x divided by 2 is negative 2x, and 12 divided by 2 is 6. All right, and there it is. That's our answer. Y is equal to negative 2x plus 6. All right, this last one says solve x over 3 plus 6y equals 2 for x. I'm going to rewrite that just so that I can have some space. So it's x over 3 plus 6y equals 2, and we are solving for x. All right, couple of things are going on here. We have x divided by 3 as a term. So we're going to solve for this term last and go ahead and take care of 6y that's attached by addition. All right, we're going to draw our line down the equals. And now it says move the variable you're solving for to the left. It's already on the left side. And now we're just working on moving everything to the right. So here, subtract 6y, so we can get rid of that. 2 minus 6y. Remember, 2 and 6y are not like terms, right? So this is 2 minus 6y equals, the 6y's cancel, x over 3. And now the only thing we need to get rid of on this left side is this dividing by 3. The inverse of division is multiplication, so we need to multiply both sides of our equation by 3 in order to get rid of our denominator. So we're left with what we want, which is x, right? Equals, and now look, there's parentheses. We just created a distributive property, so we need to distribute the 3 to the negative 6y and the 3 to the 2. 3 times 2 is 6, minus 3 times this negative 6y is negative 18y. And x is by itself. All right, that's it.